Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to do a little bit more enhancements, if you will, to the PowerMatic drill press. You've seen this drill press in several of my videos. I actually did an introduction on it, showed some repairs I had to make. I did a video on putting the kill switch on it, and I also did a video on making this table. If you recall, this drill press has a coolant tray base to it, trough around it with a drain in the back. But to make it more useful for me here in the shop, instead of trying to set blocks up on here where I could drill through the material, I made this plate. I put this piece on the back of the drill press, on the base of it, with a couple holes, and put some pins in this plate. That lines up, and this plate doesn't move then. It's stationary. I've got an inch clearance under the bottom of it. But in the video where I made this, I also drilled these 8 holes in here to put these stops in. And I think you've seen me use these stops before, where I'd be drilling something like this. And in a recent video, several of you pointed out that as good as these stops were, they didn't prevent the piece from rising up. And if you were drilling soft material, copper, aluminum, brass, something like that, very likely the bit is going to get caught in that and try to auger up the workpiece. We're going to address that a little bit later in this video. I think I have a solution for that. But what I want to do first in today's video is put some more holes in this plate. Let me get it up. As you can see now, there's holes on what we'll call the X and Y axis. What I want to do is put 2 holes in each of the 4 diagonals. Now, it would not be very easy to drill those here on this press, simply because the feet wouldn't necessarily line up on the table. If I took the feet off, then I'd be drilling down to the table. And to do it on the mill, I would have to do a diagonal setup and do on the 4 holes on the x-axis, then change it around to this diagonal, because my little mill does not have enough travel on the Y to get this row and this row. So we'd have to do 2 setups on the mill. Plus I'd have to take the mill vise off of the mill and then tram it back, put it back on and tram it in afterwards. So let's go over to the workbench and I'll show you what I think is going to be the solution for, my easiest solution for drilling these 8 holes. Alright, I'm over at the workbench now. I got some die-chem on my, on this drill press plate. Let's lay out the diagonal. Let me grab my scribe right quick. Alright, we're going to lay out the diagonal. Now I would like these holes that I'm going to put on the diagonals, I like them on the same line, if you will, as these holes on the XY. So what I did was take my calipers and measure the distance from the inside of the center hole to the inside of one of these holes. Then added a 1/4 inch to it to get it to the center. So that should give us our radius for the close line. Then I did the same thing, measured out to one of the outside holes and added a 1/4 inch to it. And as I did that, It reminded me these holes are 2 inches apart. So we should have our holes in a uniform pattern all the way around. Okay, now we've got our holes laid out. We're ready to drill them. And as I said, if I tried to set this up on the mill with this line on the x-axis, I would have to turn it 90 degrees to do the other axis. Plus, I'd have to take the vise off of the mill, and then have to put it back on, tram it in. If I tried this on the drill press, I would have to prop it up high enough, and again, you got that issue of twisting. I'm definitely not going to do this with a hand drill. Here's my solution for this. We're going to use the mag drill. I've shown this mag drill in a couple other videos. One in particular where I drilled a great deal number of holes in the top of my welding table using this and an annular bit. We've used it on several other projects. This really doesn't have a brand name to it. It's made in England, but it has been a real good tool here in the tin barn since I acquired it, and basically I'm not going to say I rebuilt it. I took it apart, cleaned it up, give it a paint job. It's had a drop at some point in its life. Let me see if I can pull that up a little bit. A little hole or a little break in the plastic right here. Before I actually start using this, I want to say just a word of caution about mag drills. Now, one of the most famous YouTubers, as far as in the machinist world, got a mag drill not long ago, and he was demonstrating its use on a vertical beam, where he put the magnet up like this, engaged it, and drilled a hole in that beam. I cringed when I saw him do that. Never ever put a mag drill on a vertical beam or straight upside down from this without strapping it down. Now, it's meant to be used on a vertical beam, to set it up like such, engage the magnet, and it's even meant to be used upside down. But always, always strap it down. Let's say you got it upside down and you're drilling. Now, you may take precautions and get out of the way of it or whatever, should it try to twist. But what if you get that bit hung up and trip a breaker? Or what if the power goes off? This thing's going to come falling down, and it's going to come falling down hard and probably totally destroy it. Same thing on a vertical beam. If you got this at a 90-degree angle, strap it. Run a strap through this and around the beam, because you can trip your breaker. Something should happen in the motor here, and the motor up here, the magnet's down here. But again, any number of reasons the power could go off. So always have it strapped down when you're either upside down or on a horizontal or vertical beam. All right, let's get this. All right, I just engaged the magnet. And you shouldn't have to worry about this twisting because it's all one unit. Alright, I think I need to get a little sharper bit, but that was our first pilot hole, if you will. Now we'll go with a 1/2 inch bit. Don't know whether you can hear it in the video or not, but this magnet's doing a little bit of humming right now. That's just characteristic of electromagnet. Now one more thing while we're in place, and I'm going to do tool changes on this job instead of drilling all my lead holes and then going back and drilling all my holes and then all my countersinks. It's just easier once you're set up in place to do all the tasks. Oops, and I'm bottoming out there. I may have to get a longer countersink or see if I can drop this one down some. Alright, I got 7 more of these to do. I'm not going to bore you with that whole procedure. I will quickly do one more when I get a sharper bit here. And all I'm going to do is release the magnet. We'll put our other bit back in for lining up. Folks, this is just so much better than trying to use a hand drill. Much safer, much easier. I'm going to drill the other 6 holes, clean this up, then we'll go back to the drill press, and again I will address the issue of holding the workpiece down as well as keeping it from twisting. Alright, there's our plate with the diagonal holes cut in it. As I was drilling those holes, you know, when you're doing something like that, all kinds of thoughts run through your head. And I never keep my cell phone in my pocket when I'm doing work around machinery like this, just primarily because I'm afraid I'll bump up against something. But the thought crossed my mind, is that magnet in this mag drill strong enough to mess up a smartphone should I've been working on a large metal table and have my phone laid on it? So I decided I would look that up on Google, and I had to basically laugh out loud. The first article said absolutely not. No way will a magnet mess up your smartphone. Second article said absolutely. A magnet, strong magnet, can distort your sound on a smartphone. The first article, I think, was talking more about the storage on it, which is solid state, nothing magnetic in that. Second article was talking about the speaker on your smartphones, which do have a magnet in them as well. So I think it's wise to not have your smartphone around strong magnets. All right, I'm going to clean this up, get this die-chem off of it, deburr the bottom side if it needs it, and meet you back over at the drill press. And again, we'll look at the safety issue of the drill bit augering up your piece of work, your work material. All right, I've got our little table setting back on the drill press. Remember, we got pins back here in the back that's going to keep it from trying to twist. We've got our new diagonal holes, and I've checked the fit on all of them. And again, what these are used for, put a piece in while you're drilling it, set the stop in, and that keeps it from twisting, like we know will happen and mess up a hand if you're not careful. But what about the augering up that several of you expressed concern about, of just having this? Well, there's this plain simple solution, a drill press clamp. But you guys know me, and I had to pragmatize it a little bit. I was hoping I could just take the nut off and it would wedge in the existing holes. But the existing holes are 1/2 inch, and this is 12 millimeter. And that is enough slack in there that it would not wedge in. I tried making a sleeve to go over this, but you know the difference between a 12 millimeter and a 1/2 inch hole only left, I'm guessing right now, probably 8 or 9 thousandths on each side. Real thin, almost razor blade thin shim that I put in there. And that worked, but I really wanted to keep this somewhat like it came. I bought this one originally to use out on my in the hardy hole on the anvil. I could slide this through the anvil, put that down, and that would make a quick hold fast for material. But like I say, I had to pragmatize it just a little bit to work on this. Number one, the pin that was on this was just a thread or two too long, and I didn't want to make new legs right now, so I simply cut that off. Now this nut is obviously way too thick to go under there, so I went to Lowe's to look for some flange nuts, 18 millimeter. And y'all have heard me lament about the local Lowe's we have here numerous times. But I was over in the hardware section. I had already gone to the Hillman bin and got these. And I walked over to the tool section, and was headed toward the vice grip area. Thought maybe they would have one of these, and I'd pick up an extra one while I was there. The guy that works there came up to me, wanted to know if he could help me, and I tried to describe to him what I was looking for. That it was basically half a vice grip, or a vice grip with only one jaw, and on the other side had a pin that went through your table on the drill press. And he almost belittled me a little bit. And I've never seen anything or heard of anything like that in my life. I don't know what you're talking about. He said, "Can you show me a picture?" I said, "I sure can. I can show you a Harbor Freight picture." And I'd already pulled it up in my phone before going to Lowe's just to see if I could find what this was, what diameter or what length the shaft was. But anyhow, I pulled it up on the phone. He looked at it. He says, "I've worked in the tool section of Lowe's for 20 years, and I've never seen anything like that before. We don't have such a thing." Okay, buddy, you don't have to get belligerent about it. I didn't tell him that, but that was my thought. But anyhow, that's something I'll do next time I go to Harbor Freight, is pick up another one or two of these. I would like to have the capability of clamping it in two spots. As I say, this was 18 millimeter. I got a flange nut so it could easily set on a wrench. Let me get this stuff out of the way. I thought about just making longer legs for this table so I could reach underneath it. I got plenty of lift. I've got another foot of lift on this drill press should I need it in the head. But I don't have any more pins right now, and would have had to put longer pins in here. I could raise it about a ½ inch now. But this works fine. Just slide that underneath, line it up. And it does not have to be tight at all, as a matter of fact. Keep it loose. So then I could put my work stop back here. Remember, it's going to try to twist that way. Line up my hole and simply clamp that down. Now this particular clamp, I don't know whether it's sprung, whether it's bent, but it has a 1/4 inch clearance. It will not, this is screwed all the way in now, and it will not clamp anything any thinner than 1/4 inch. So what I may do, if that's the case next time I pick up one, I may weld just a small little, about 1/4 inch plate on this existing foot here, and then that way I could clamp very thin material if necessary. Okay folks, I realize this has been a somewhat simple video, just drilling some holes and demonstrating the use of a vise or a drill press clamp. But this was something that was suggested by you guys, you viewers. Several of you pointed out again that as good as these work stops back here were, that would not stop it from augering up on especially a thin piece. And you suggested I get a clamp, or you suggested I find a way to clamp the workpiece down as well. So I hope you got a little bit of enjoyment and pleasure out of watching this. And again, I appreciate all the comments on the videos. I do read them. I don't always respond to all of them, but I do read them, and I wholeheartedly appreciate them. Take care, and I'll see you on the next video.